What's up YouTube? My name's Quickie, welcome back to the channel. This is day 6 of man flu, so I am sorry the way I sound. There's nothing I can do about it, so there you go. The video you just saw was putting together this thing. That's because today we're going to be bending some tube. Steve-O's on his way down, should be here shortly, but we are basically going to try and get the seat hoop mocked up to a point where he's happy with it, so I can go through and finish weld it, put the tags in, various other bits and pieces. So we're going to be needing this thing today. Now, this is a JD2 Model 3 manual tube bender, and it is really cool. I use it for some of the other stuff that I make, and it's just brilliant. It does exactly what it's supposed to, which is awesome. But it is very versatile. Now, the last video I praised up Andy. This video I'm going to make mention of another YouTube creator. It's called the Fabrication Series. The guy that runs it is called Justin. He lives in a sandbox, basically Las Vegas, and he is awesome with one of these things. I'll put a link into his channel in the descriptions, one of those little clicky things and whatever, so you can go and check him out. But it is well worth watching if you want to get into this. Pretty much everything I learned about YouTube, about tube bending, I learned on YouTube from Justin. So again, a really cool guy. I've messaged him a couple of times with a few questions, and he's more than up for replying. Very helpful guy. He is American, so he uses 40 words where maybe 20 would do. But they all do that. I don't know why, but they just do. The other thing is he talks really quickly. I mean, so fast. So me being me, I had to watch his videos quite a few times. It could just be a ploy to get his number of views up, I'm not sure. But the boy knows his stuff. He really does. The link I'll throw up is he used to build roll cages, like time attack roll cages. And it's all built in situ in the car and everything else. He does an incredible job, and he's got a YouTube series that literally takes you from the very start, so planning it all out, to the finished article with all the finished welds and vent holes. It's really worth watching if you want to know how to do this stuff. I'm not teaching you anything. I'll let him do that because he's far better at it, and he's been doing it a long time. He's also got a tube bending basics series, which you'll find in one of his playlists, but it talks you through making up a cheater and a bend gauge and how you would use them and how you calculate the bends and where the bend needs to start and stop. And just go watch it, it's well worth it. So that's the plan today. Seat hoop. So first things first, I want to make a bend gauge. The die we're using I haven't used before. The die is the thing that you actually bend the pipe around to get the shape, and this is the bar that we're going to be using, the tube that we're going to be using. So it's 1 inch thick, or 25.4 if you live in the UK. And it's 2.64mm wall thickness, so it's quite sturdy stuff. And considering Steve-O's going to be sitting on it, it's not a bad thing. So anyway, a bend gauge basically is needed so you can work out how much material you're going to need to make any given bend. As it goes round the die and it bends the pipe, the outside of the pipe will stretch a little bit and the inside of the pipe is under compression. So basically you need more pipe than you actually think you do. So this is where we do it. If ever I get a new die, I make a bend gauge and a cheater for it. A cheater is just a 90-degree bend with the start and end point of the bend marked off on it. So you can offer it up and see what sort of angle you need to go and all that kind of stuff. A bend gauge is purely there to figure out how much material you're going to need. Go check out Justin's channel because he's going to explain this way better than I do. So in order to do it, I've just cut off a piece of tube. It's 50mm in length, and we're going to mark a few bits and pieces out on it. So forgive myself, say, I don't know, 10mm. So 10mm sticking out. This is where the follower is actually going to be lined up. I'll show all this in a minute. And then all we're going to do is mark out in sort of 20mm increments, just a smaller mark, so I've got a reference. 20, 22. No idea how much I'm going to need, but you can always rub these marks off. So I tend to go overboard. Right, that'll probably do. Stick a couple more in. Yeah, that'll be fine. So what we're going to do now is put this into the tube bender. This is going to be my start point, which I'll show you in a sec. And then we're basically just going to put a 90-degree bend in this. The tool I'm using has a 3-inch radius, so it's centerline radius. So it's going to something like that. And when we get to 90 degrees, we'll mark it again, and then from there we can figure out how much material a 90-degree bend is going to require on this size of tube. Okay, so back at the tube bender, we've got our tube with all the marks on it, as you just see me make up. This is going to go into the tube bender here. Ooh, let's see if you can see this. Okay, so this piece here, this is the die. This is what the tube is going to be bent around to actually give it the shape. This silver piece here is the follower. So basically you just need a point of reference. So all we're going to do is put the tube in until our first mark, where is it? You can't see anything. Right, see the big line? Big line just there, and then the smaller lines carry on. Yeah? So that is going to be pushed back until it is right in line with this follower. That one there. We'll clamp it all in position, make sure that line's in the right place, and then we'll be ready to do some bending. Now I want to get the little hash marks that you saw me do previously, I want to get them on top, because essentially then they're following the center line of the bend. Let me get this set up and I will bring you back once it's all kind of where it needs to be, but that's basically all you're doing. So what we've got is our mark here. Where are we? So the mark is right on the follower. This is all just clamped in. So there's a pin that goes through, goes around the bar, sorry, the tube, and then this locking bolt just winds out and holds everything in position. This pin is just a pivot, so that's going to be the center of rotation once we start bending this. This pin just goes through one of these holes in the die to lock it in place. So as I move this arm, I don't know if you can see that, it will move the die. If we go around the back, you can see the tube is going through the follower, and it's got two sort of arms here and another one there that actually grip on and guide the outside of the tube. So that keeps everything nice and straight. So basically, by exerting pressure on it and moving this arm this way, you'll draw the tube this way and it will bend it around the die. That's the idea anyway. This is just a degree indicator, so you can move this, you can lock it in position. The idea is that you preload the arm so it's under tension. You set your dial to 0 and lock it off in place, and then start bending. And as you bend more, this piece of wire will move around the scale, and we want to get basically 90 degrees all the way around there. We should end up with a 90 degree bend. We'll check that. Tube does spring back, so if you just crank it up to 90 degrees and let go, it will actually move back a bit. So you tend to have to over bend it, and it's always a bit of a thing with a new sort of new tube. You don't really know how much spring back it's going to have until you try to do something with it. So let's give this a go. So preload, that's on 0, I'll lock it in place. Yep. Because this is designed in a very clever way, you do it in little steps, and it doesn't take a great deal of effort to bend some really chunky pipe actually. Really chunky pipe. This will go up to, I want to say 2.5 inches, but I could be wrong. But it is impressive what it can do. Got to the end of travel on the first hole. So what we can now do is take this out, move the arm around to the next hole. Who's ringing? Stop ringing! I'm not doing this again. It's probably Steve though. I'm not. And carry on. So where are we? 17. It looks like there's about 5 degrees spring back on this. I can pull it up to 85 degrees. Take the pressure off, well, a little bit less maybe. It goes back to 81 degrees. Interesting. So that's 90 degrees now. I'll back off, I lose 4 degrees. So I'm going to sneak up on this, we'll go to 3 degrees. Yeah, we're still about 1 degree off. Take it to 94. And that is 90 degrees. 90 degrees. Okay. All the pressure's off the arm. It's not even connected. So this in theory should be a 90 degree bend. Happy days. You can just go online and buy all the tubes bent ready so you can just stick them straight on your bike, but considering the amount of stuff I do actually bend up the tube. Stop ringing and texting and leaving me messages. It is a very, very handy tool to have. on a 90-degree bend. Sweet. Okay, that's the bend done. This is the reason why I put the hash marks to the top when I'm actually doing the bending, is that then they follow the center line radius of the bend. This mark here is where the follower was sitting when we started the bend. Then each of these increments is 20 mil. So an easy way to find out how much tube is going to take to complete a bend, if you take a straight edge and put it up to the center of the tube, you can see where the bend basically starts and stops. So in this case we're looking for where it stops. The other thing you can do is, if you have a close look at it, and sometimes feel it as well, you'll feel a little depression or see a little witness mark on the tube as to where it stopped experiencing any load in the bender. Another way is just obviously with a straight edge, and where it comes down to a V, I can see that the bend actually stops about there. So for this side tube going around that die, we now know to get a 90-degree bend out of it, we're going to need 20, 40, 60, 80, 90, 100, just over 110, maybe 112 mil to complete a 90-degree bend, which is handy to know. So if you were doing something that went along, then another bend, and then a 45, for example, each of these bends is 90 degrees, so that would be 112 mil. This would be 112 mil, and the 45 degree bend would obviously be half of this. So what's that, 56? And then whatever the gap is that you want between the bends, so that distance, this distance, and this distance, you would add to it, add the whole lot together, and that's the minimum length of tube that you would need to cut in order to do that in one seamless piece. It's always a good idea to give yourself a little bit of extra. Depending on how you're going to be connecting it or coping it or whatever, you'll need extra anyway. But that is the basics of it, really. Let's just see how close to 90 this is. It's not bad. So, there you can see a 90-degree bend. Another way that we can do it, I've got a digital protractor, which I'm going to do as well anyway. Here it is. This thing. Very cool piece of kit. Essentially, turn it on. It's magnetic, and if you stick it on something, it will tell you whatever the angle is. You can't assume that the bench is level, but what you can do is stick this on there, set that to 0, take it off and put it on here, and then check that angle in reference to the first one. It's, you know, with anything like this, it's belt and braces, so the more you measure it and the happier you are that you're actually getting the bends that you expected and all that kind of stuff, then the better it will be. So measure twice, as the old saying goes. Now Steve-O is talking about he wants to put on one of those little LED lights set into the seat tube. So we're toying with the idea of having the bend, then a straight bit, and then another bend to follow it back, which is fine. I mean, this is going to be a modern cafe racer. Basically on the flat part of the rear section, that's where we can inset the light. It's just a case of slotting this out and backing it, so that's easy enough. However, on this tube bender, I can't do there's a bend, then a 2-inch gap, and then another bend. The minimum I think I can do on this is 4 inches. There aren't actually that many tube benders that you can do, and the reason being is that the way that the follower and the die is set, if you try and move the tube through and then just carry on bending, it doesn't hook up properly in the die and you'll get a funny shaped bend. Certainly the degrees won't mean anything anymore. So what we're probably going to end up doing is doing a complete 180, splitting it down the middle. That way he can decide how far apart he wants them, all this kind of stuff. Then all I'll do is cut another section of tube. We'll put some inserts into the end of the tube. He can decide how far apart he wants it, and then we'll weld it there. So the next thing I'll do is a 180 version of this. First bit, I can use this as a cheater. So this would just be where I offer it up to, any given space to see what sort of degrees I need to put into the bend. I've got angle finders and all sorts of other stuff as well which we can use, but it's handy just to have a known bend radius and degrees, that you can offer it up and get a really good feel for, is that right, is it wrong, how much more do I need, all that sort of stuff. So it's really good. It's a really simple way to do it. And the telltales that you can see in the metalwork give you the start and end position of the bend, so it's all good. Anyway, Justin explains it a lot better. Go watch his videos because the guy is awesome, and he'll explain it far better than I have. Anyway, on to the 180.